Hold on, I need to close some stuff out here to close the calendar out. Okay, now hopefully I'm not covering anything up.
Nope.
Okay. In other words, the average rate of change is the total change divided by it's basically rise over run, right? If you have a function that looks something like this, and you want the average rate of change between there and there, we're going to take the slope of that secant line, which is the f of 4. This is f of, or excuse me, this is n of $3 minus n of $2, all divided by 3 minus 2. In the same way, we would get the average rate of change between this point and this point. So if we do that, we plug in 3, we have 100 minus 45, so n of 3 is 55. N of 2 is 80. So we know this is going to be a positive, so I really probably want to take the rate of change between n of 2 minus n of 3. So it's actually 80 minus 55 divided by 3 minus 2. So the average rate of change is 25. Let me think about this for a second. We have the answers in here, or what's in this box here? Is that what you put in?
Yeah, so that's the correct answer, and then the two below it are also the correct answers. So to do credit, to get credit, we actually have to do similar exercise.
Okay, I was right in the first place. It was n of 3 minus n of 2, so we ended up with negative 25 divided by 3 minus 2. So that's how you get negative 25.
Yeah, so actually if you want to hit similar exercise, it would bring up a brand new one so that we can get credit for B and C.
Okay. Shall we look at B and C first? Find the instantaneous rate of change of demand when the price is 2. So how are we going to do that one?
Yeah, I didn't know how to do these.
Well, instantaneous rate of change is first derivative. So if we take the first derivative of this and evaluate it at 2, that'll give us instantaneous rate of change. That's what calculus is all about, is not average rate of change, but instantaneous rate of change. So, do you know how to take the derivative of that?
No.
Okay. They're probably having you use the formula f of x minus f of a all over x minus a, perhaps? Does that sound
Yeah,
good?
it sounds familiar.
Okay, let's use that. Give me a moment to make sure I get it right. And the reason is that once you learn the power rule, how to differentiate, you never ever do these again. So I don't do them very often. Let me look, make sure I get the right formula. I think it's what I said. I'm curious Yeah. It is the derivative, but if they haven't taught you how to differentiate yet, they probably have taught you this in order to answer this question.
Well, see, this is an online class. I don't actually get taught anything.
Well, I meant the material that you're supposed to have covered, however you cover it. In other words, if I was doing this, I would apply the power rule and substitute 2. It's much simpler. And I'm happy to teach you the power rule. So they never make you show your work then?
No, it's all online.
Okay. Let's see what happens if we apply this definition. F of x is 100 minus 5x squared. We'll use x instead of p. Minus f of c, c being $2. So when we evaluate $2 there, we get 80. All over x minus 2. So if we simplify this, what do we get? We get 20 minus 5x squared in the numerator, and in the denominator x minus 2. And now to evaluate that at 2, what does that give us? 0. Well, I'm going to have to show you the easy way to do it. Since I don't apparently know how to do it this way, I just would have to spend some time reviewing that.
And it may be easier to try it with all new numbers, because I don't know if it'll
For the similar problem, it won't matter. Let's make sure that my method works. Let's figure out n prime of p, first derivative. Well, if I apply the power rule, that goes to 0. And if I apply the power rule to the second part of it, it becomes minus 10p to the 1. Do you know the power rule at all?
No.
Okay, here's how it works. You take the exponent, you drop it in front. So y prime is equal to 2x, and then you reduce the exponent by 1. So if y was 3x to the 4th power, y prime would be the exponent times the coefficient times x, reduce the exponent by 1. So that's how I got this.
Okay.
Okay? And now notice how easy it is to evaluate n prime at 2. Plug in 2 for p, and you get minus 20. So using the power rule to differentiate is tremendously more easy than what they're going to force you to learn, which is going to be the limit quotient definition. And I'm not quite sure why they teach calculus this way, but they will. They'll make you do it the hard way. It's like teaching a person to ski by starting them off on the expert slopes. And that's what they're going to do, and it's going to be confusing, but eventually when you get through that and they teach you the simple ways of doing derivatives, it makes it a whole lot easier. And applying the power rule is the simplest way of all of doing a derivative. And let's look at the third part of this. The instantaneous rate of change of demand when the price is $3. Well, what was my first derivative? It was minus 10p. So when p is 3, it's minus 30. See how easy it is? Once you know the first derivative, these become easy. Okay, So what do I have to do to find a similar? Go down and click on similar exercise?
Yeah.
Okay, let's do that. All right, what's the average rate of change in price from $2 to $3? Remember how we did it?
Not really, because I was waiting to take notes with the new numbers.
Okay. We're going to take the change in the function, in other words, n of 2 minus n of 3, and divide it by 3 minus 2, the difference between these two. The numerator is the difference of the function evaluated at these prices. The denominator is just the difference of the prices. So what's n of 2?
Is it 90 minus 4, 2 squared?
Yeah. So that's 90 minus 16 at 74. Do I have that right?
Yeah.
You better check my math here if you have a calculator handy. And then what is n of 3?
90 minus 4 times 3 squared.
So that's 90 minus 36, which is 54. All over 1. So the average rate of change is 20.
I'm going to grab my calculator quick.
Okay, hold on before we put that in an answer. In fact, remember how I did it, what I thought was incorrect the first time because I did it n of 3 minus n of 2? And then I thought the answer to the previous problem was positive, so I decided that I needed to do n of 2 minus n of 3. And then when I looked at your answer on the previous problem, it was negative, and so I had done it right the first time. So I need to do this right the first time also. We don't want to get the wrong answer here. It is 54 minus 74. In other words, it is n of 3 minus n of 2, which gives you a negative 20 instead of positive 20. We good with putting it in there?
Yeah.
Okay. Find the instantaneous rate of change. Okay, let's go through it one more time on how we get the derivative.
Is it
To get
8?
Well, let's write the derivative function. That's going to be helpful to you. The constants go to 0, always. If you have a constant added to a function, and you take the derivative of any constant, it's 0. So the derivative of 90 is 0. Minus 8p to the first power. So the derivative function is minus 8p. So when it's $2, what is it?
Negative 16.
And when it's $3, what is it?
Negative 24.
Now what? Hit this arrow?
Yep.
And that was 21, right? Or no, this
No,
is
that was
21?
20.
Okay, so this is
Yeah.
21. Okay, all of these look like they're going to be very, very similar.
I got the first part of it. And
104.
then now that I know,
Okay.
yeah, I didn't know how to do the instantaneous rate of
Okay.
change.
So what is H prime of W? The prime means first derivative.
So it's going to be 0.22 W.
Okay, use the same rule on this. Multiply by 1, and then you're left with W to the 0, which is just also 1. In other words, when you take the derivative of a linear function, it's just the coefficient, minus 0.4. And when you take the derivative of this constant, it's 0. So this is our first derivative function. So what is H prime of 350? Do you know how to do that in your calculator?
No.
If I say f of x equals x cubed, what is f of 2? How do you solve for it? You plug in whatever is in the parentheses in place of x. So that's equal to 2 cubed. So
Okay.
what is h prime of 350?
0.22 times 350 minus 0.4 times 350.
There's no 350 on the 0.4. Notice that there's no w up here. In other words, we're only going to plug in this what's inside the parentheses wherever there's a w. Okay, so do you have your calculator? What is that?
77 minus 0.4, 76.6.
76.6?
Correct.
I guess that was it, huh? So
Yeah,
we want to go to 25 or 22?
22.
How are we going to get the average rate of change between those years?
The difference divided by...
The difference of what? Because we got two things here. We got x's and we got y's. It's the difference
y
of...
minus x.
Well, it's the difference in the y's is the numerator, and the difference in the x's is the denominator. So what's the difference in the y's from 1905 to 1955? Went from 1,007 to 216.
$791.
Negative, because it went down. Okay, so minus 7, what was it, 791?
Yeah.
Divided by how many years? Because we want an average, which is an average immigrants per year. So difference between 1905 and 1955?
50 years.
So what is this number?
15.82.
We're supposed to do it to 3 decimal points?
There's only 2.
What was it? 15?
0.82.
And that's rounded? Or not?
No, it's done.
Oh, that's
Yeah, just
not rounded. Okay. 15, and it's minus, right? Minus 15.82, because the years is positive. So the numerator is negative, but the years is positive. And that tells us that we're losing immigrants per year by getting a negative answer. We're not gaining it. Uh-oh. Hold on. Let me check this math. Let's see. 1007 minus 216 equals 791 divided by 50 equals 15.82. How can it not be negative? How many chances we get here?
3 or 2.
And we've taken 1?
Yeah, we can just try it. Just 15.82.
But that doesn't make any sense. It can't be positive. Let's see. We go, that's 5 years, 10 years, 15 years, 20 years, 25 years. No, it's 10 years per. So it's 10 years, 20 years, 30 years, 40 years, 50 years. I'm stumped. I'll try it with a plus, but could I have used the wrong 15.82? There's no way this can be right. The average rate of change is f of b minus f of a all over b minus a. Is that not what we did?
I don't know.
This the y is f of, this point is f of b, this point is f of a, and b minus a is 50. Have you ever come across a typo before like that?
Yeah, I can actually email my professor about it because that's what we did. It's the right answer.
Sure seems like it should be. Should I hit done here?
Yeah, and then if you just want to click on 23,
Is it not? It's not gonna ask me B through E.
No, not unless you get that one right.
All right.
And then say yes.
All right. This one is not so easy to apply the power rule, because the exponent is the variable. approximate the limit. There's two formulas for finding the instantaneous rate of change. One is the one I gave you, and the other one is f of x plus h minus f of x all over h, and taking the limit of that as h goes to 0. You apparently have had this, and that's fine. This is the hard part that I was telling you about. In other words, before they're going to let you use the power rule, you're going to have to learn to differentiate using this definition. So what is if f of x is 7 times x raised to the natural log of x, what is f of x plus h?
Uh, 7x to the natural log of x.
Well, first of all, 7x plus h raised to the natural log of x plus h. In other words, wherever we find x, we plug in x plus h. Okay, and then I got to subtract from that 7x to the natural log of x. Then I divide the whole thing by h. And so f prime.
Why don't you do the same thing when you subtract? Why is
because it's subtracting f of x, not f of x plus h.
Oh,
in other words, the definition of first derivative, this is how the power rule was derived. This is how the product rule, the chain rule, and the quotient rule. You're going to learn all of those rules, and the way they were derived was by this definition here. And so no matter what the function is, you can plug it in to this definition. The problem is that simplifying this is not so simple, as you can see. And I'm shocked by the degree of difficulty of this problem. Because they don't want you to simplify it. They want us to try some h's and see what we get as h approaches 0. In other words, I haven't quite written this correctly. F prime of x is equal to the limit of this as h goes to 0. So let's evaluate this thing. We can do what they're asking now that I get what they're asking. Using smaller and smaller h's. Let's start with an h of 1. What is this function evaluate at h equals 1? Well, all I'm going to do is plug in 1. So it would be 7 times x plus 1 raised to the natural log of x plus 1. We're going to evaluate this at x equal 2 minus 7x natural log of x all over 1. Okay, you with me?
Yep.
Now let's plug in 2 and see what number we have. In other words, let's evaluate f prime of 2. I'm not sure what to call this, whether it's f prime or not. But it's 7 times, when x is 2, this is 3, raised to the natural log of 3 minus 7 times 3 raised to the natural log of 2. Did I do that right? No. Yes. No, I didn't. This is 7 times 2 raised to the natural log of 2, all over 1. Now you should be able to come up with a number for this.
Hold on, so we're writing it out.
This is a tough problem, because when you start evaluating this, you're going to get it out to several decimal places. And they don't want you to round until you get your final answer, which means doesn't mean anything. Go ahead and give it to me to 4 decimal places. Because what we're doing is approximating what this thing's going to do. We're going to then solve it for h equal 0.5, and then we're going to solve it for h equal 0.1. And we're going to see what number we're approaching. That's basically what you do when you take the limit of something as h goes to 0.
Okay, so I got 17.0358.
17.0358. Okay, that's when h is equal to 1. Now let's let h equal, guess we could go directly to 0.1. Let's not go through half. Let's go directly to 0.1. Okay, so we're going to plug it back into this limit definition. So now we're talking about taking the limit of 7 times, I'm going to go ahead and write 2 in place of x, 2 plus 0.1 raised to the natural log of 2 plus 0.1 minus 7 times 2 raised to the natural log of 2, all divided by 0.1. Boy, you're going to need to be really careful with your math here.
Yeah.
That would help you, but my TI-84, the batteries are blown, and when I put new batteries in, I couldn't get it to start up again. And I have an app on my smartphone that does this kind of stuff, but I got to use that virtual keyboard, and it's almost impossible for me to do anything without making a mistake.
$8.2084.
Let's try it one more time with an h equal to 0.01. We're going to take it down by a factor of 10 each time. Now, use the approximating the limit by using smaller and smaller values of h to find the instantaneous rate of change. How are we supposed to know when we've taken it down far enough?
Do not know.
Well, let's do it for 0.01 and then call that our answer. So, with h being 0.01, we're going to evaluate the following. 7 times 2 plus 0.01 raised to the natural log of 2 plus 0.01 minus 7 times 2 raised to the natural log of 2, all divided by 0.01. I don't know, are you doing this all in one step, or are you doing it piecemeal like I would probably do it?
I've got it all in one step with all the parentheses and
Good for
stuff.
you. Good for you. If you know how to do that and you get all your parentheses right, then it makes it easier to do successive iterations, I guess, huh?
Yeah.
Yeah, because if I was doing it, I'd have to do it piecemeal and I'd have to repeat it every single time.
So that one I got 7.8807.
I'd say we go with that answer. We're not really honing in very fast on it. In other words, if we do 0.001, they don't say how many. If you can try it quick, go ahead. I'm puzzled by their instructions. Do not round until the final answer. Well, there is no final answer. We could do 1,000 more iterations, and h is never going to be 0.
Yeah. So 0.001 is 7.8483.
Okay, we're definitely getting closer to what should be the final answer. I say we go with that.
Okay.
Otherwise, we could spend, I don't know, an arbitrary amount of time. 7.8483. 7.8483. And they even used the same exact 3 numbers we did. Until 2 evaluations yield the same answer.
Okay, so that's 0001.
Yeah. Should I X this sorry? We're going to get another chance, right?
Yeah.
I guess they mean the same answer to 4 decimal places. This is a crazy problem. Don't really like this problem. It does. I guess it facilitates your learning it. I guess it does. It's not as bad as I thought. They make it so difficult that you can't do it the easy way, because finding the derivative of that function is that would require a half an hour to teach you that technique of how to find the derivative. That's quite complicated. More than a half hour.
So on that one, got 7.8451.
This is crazy. Okay.
But I say we try that one because it'll probably give us a third try, and if that doesn't work, we'll go.
Okay. 8451.
Oh my God.
I know it. This is crazy. I feel bad for you that that this is happening, but their instructions are so poor.
So how many zeros are we at now?
Well,
4.
I can only imagine. Yeah, we're at 3 zeros. Decimal point 3 zeros produced that answer.
Okay.
So I can only imagine that we have to keep going lower until we get the same answer to 4 decimal points. Here's a thought. Let's just skip all the others. As long as you got it in there, let's try h equal to 0.00000001. That has to be it, doesn't it? Doesn't that have to be accurate to 4 decimal points? Almost guaranteed.
I guess, yeah.
And why go through all the other steps? In fact, add a few more zeros if you want. Just add a bunch of zeros. Let it truly approach 0, and we'll get the answer they're looking for. You could try it with 6 zeros and try it with 7 zeros and see if you get the same answer, if you can do it easily to 4 decimal points.
So it looks like can you go past 8 o'clock? Because I was hoping to
Yeah, I got no problem.
finish. Okay. All right, so I'm just going to do 6 zeros, I guess.
Okay.
Okay, I think it worked. 7.8448. And that's the same answer I got with using 4 zeros.
Okay.
So I used 6, but I got the same answer with 4.
Okay, good. That's got to be it then. 8448.
Yeah.
Rounded off properly?
Yeah.
Wow.
That was ridiculous.
That may be the worst problem I've ever seen since I've been tutoring. Okay, let's see. 25 next? Oh, no. Do we have more to do on this?
No. So
Okay.
22.
Oh, 22, right. Okay.
Yeah, I kind of just jumped around. I tried to do as
Well,
much.
22 is the one that we couldn't figure out their answer.
Yes, you're right. 25.
Can we do this the easy way? I guess there's no reason not, huh? Okay. So f of x is equal to 2 plus 2 times x to the minus 1. You see that?
Yeah.
Why I rewrote it like that? Because we're going to apply the power rule. What is f prime of x? What happens to this?
Be 2 minus.
All constants go to 0.
So it's just negative 2.
Minus 2, and then we have to subtract 1 from the exponent, so it's that. Notice that when you subtract 1 from a negative 1, you get negative 2. So there's the first derivative. So now just plugging in to get our answers. What is f prime of 1?
Hold on, I'm writing this down. F prime of 1 would be 1.
Okay, I'm going to plug in 2. So I have minus 2 times 1 to the negative 2. What is 1 to any power?
1.
Okay.
Or 0.
No, it's 1.
1. Okay.
Because it's 1 over 1 squared. That's what 1 to the negative 2, I can write it like this. It's always the reciprocal to the positive exponent. So this whole thing is 1.
So it's just negative 2.
Negative 2. F is 2 plus 2 times x to the minus 1. The derivative of that is 0 minus 2x to the minus 2. So f of 1 has to be minus 2. I feel like I'm living in a parallel universe here where the laws of math all of a sudden don't apply.
They never apply for me, so it's okay.
Well, use the 4-step process to evaluate this. All right, f of x is 2 plus 2 over x. All right, let's do it the hard way.
So I did an example earlier, and their problem was 6 plus 9 over x, and their answer was negative 9. So I don't know why it doesn't apply.
For f prime of 1?
Yeah, their f prime of 1 was negative 9. So the same result occurred, but it says we got it wrong.
Could I be inputting these using my wrong key? I've been using my dash. I'm wondering if it's giving, let me use my other negative. What did I say it was? Negative 2?
Yeah. Huh.
Well, let's do it the way they want us to do it. We're going to get negative 2 again, I'm quite sure, but they want us to use the f of x plus h. So tell me what f of x plus h is equal to.
So be 2 plus 2 over, oh, you already did it.
Okay, so now f of x plus h minus f of x is 2 plus 2 over x plus h minus the quantity 2 plus 2 over x all over h. When we remove the parentheses, this 2 goes away, and we're left with 2 over x plus h minus 2 over x, all over h. You need to learn how to do this anyway, because they're going to force you to do this, apparently, although I'm not sure how. Now you got to apply some fairly complex algebra. You got to find a common denominator for the numerator. That common denominator is going to be x times x plus h. So the term on the left is 2x. The term on the right is 2 times x plus h. Holler if I lose you.
Okay.
And the denominator is still h. So now the top becomes just minus 2h. I'm going to distribute the 2. So I'm going to have 2x minus 2x minus 2h. So I got a minus 2h there. Bottom, I still have that common denominator. H's do that. When I evaluate this by flipping the denominator and multiply, h's cancel. So I'm left with minus 2 over x times x plus h. And remember, we're taking the limit of this as h goes to 0. What's the limit of that as h goes to 0?
-2.
-2 over x squared. Because I have to distribute the x. X times x is x squared. X, in other words, when h is 0, the denominator is just x times x. So the derivative is equal to 2 over x squared. That's f prime of x. So f prime of 1 would be -2. F prime of 2 would be -2 over 4. F prime of 3 would be -2 over 9. Ah, I see what happened.
It's just 2, isn't it?
No, they're asking 4 questions. They put these 3 together. I thought those were the only 3. The first one is f prime of x. The first one is not f prime of 1.
Oh.
In other words, it's -2x to the -2. How do I do that here? There's the
just x, and then
which key do I
minus.
Well, I want to raise it to the -2 power.
Oh, okay. So on the left, the first column, second row. Yep.
Like that?
Yep.
Sorry about that. They fooled me by putting that there. If they'd have put that, comma, this, comma, that, I wouldn't have made that mistake. So here's our -2. F prime of 2, what did I say that was? -2/4, so that's -1/2.
You could probably just do 0.5, if not the fraction ones up there.
And -2/9. Gosh, thank goodness, I'm back to our universe. 26 next?
Yep.
Is it possible we made that same mistake on that other problem, that they were asking a different question than we were answering?
Yeah, it could have been. At least I have notes for it now.
Okay. Find the equation of the secant line through the points where x has the given values, and then the equation of the tangent line when x has the first value. Okay. This graph's something like that. So the equation, and I got that. Let's just go through how I got that. When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 2. So here's 1 point. And when x is equal to 5, we have 25 plus 5, 30. So this point is 30. So the secant line goes between those 2 points. What the equation of a line is y equal mx plus b Or do you also know the equation of a line in the point slope format?
That's what they want, is point slope.
Okay, let's write it in point slope. It's far easier that way anyway. So y sub 2 minus y sub 1 equals the slope times x sub 2 minus x sub 1. And if you ever forget that, divide both sides by x sub 2 minus x sub 1, and you get slope equals rise over run. What's our slope? This point, let's label this point 5 comma 30. Let's label this point 1 comma 2. So what's our slope?
So the 28 divided by 4 is 7.
Okay. We'll pick one of the points only. We'll pick the lower one because the math is easier. So it's actually, you know, I wrote this wrong. It's y sub 2 minus y sub 1, or y minus y sub 1. Point slope means you only have one point. So I made a mistake by putting those subscripts in there. So the equation of this secant line is y minus 2, I'm going to use this point here, equals the slope of the line 7 times x minus 1. Since they want y equals, then can I give it like that, or should I simplify it? I would say simplify it myself.
Simplify it, yeah.
We got 7x minus 7 plus 2, which is 7x minus 5. 7, can I use the letter x?
Yeah.
Minus 5. That's the equation of the secant line. The equation of the tangent line at y equal 1, to go back and look at our diagram, here's the tangent line at the lower point, x equal 1, at the first value. Well, to get the equation of that tangent line, I need its slope. Slope is what?
7.
No, that was the slope of the secant line. Notice that that's not the same slope as the tangent line. Here's the tangent line. The secant line was between the 5 and 1. They have different slopes. This slope is less. So how do we figure out the slope of the tangent line? We take the first derivative and we evaluate it at that x value. What's the first derivative of this function? If y equals x, use the power rule. What's f of prime of x? What's this part?
2x.
Plus 1. When I take the derivative of this, I got to multiply 1 times 1, and then it's 1 times x to the 0, so it's 1 times 1, so you're left with whatever the coefficient is. Okay, so I'm evaluating, and that means slope. When I write f prime of x, that's slope. So I'm going to evaluate the slope at x equal 1. Well, that means that the slope is 3 for my equation of the tangent line. So now it's y minus 2 equals 3, the slope of my tangent line, times x minus 1, using the point slope. So y is equal to 3x minus 3 plus 2. There's the equation of the tangent line. And that's the process you want to use. This is almost the quintessential question in differential calculus, is to be able to come up with the equation of the tangent line of a function at a particular point. And that's what we did. 3x minus 1. $27?
Yes. Yes.
Nah. Are they really going to make us do this all over again?
Well, at least we know this time just straight right away just go 6 or 7 zeros.
Good point.
It won't matter.
Right, exactly. So let's see, what do we want? We want f of x. Let's write it out. Let's do this methodically. So what is f of x plus h? We're going to need it. So what do? We're going to plug in x plus h wherever we see x.
Okay, so it'd be 6x plus h or to the power of 1 over x plus h.
So our function that we're going to have to evaluate at this lower limit is so put that into your thing and try an h of 6 zeros after the decimal point.
Okay.
And try an x of 4. In other words, we're going to evaluate this at a equal 4 or x equal 4. So it's really the following: 6 times 4 plus h to the 1 over 4 plus h minus 6 times 4 to the 1/4 all over h. So this is the function in your calculator that you want to plug in an h of 1/millionth. I wonder if they structured the problem to get the people who figured out that they should start with 0.000001.
Okay, so I got a big number. I don't know if I did it right. Okay. You divide it by h, we did 6 zeros, right?
Yeah, you're going to increase it by 6 zeros.
Okay, so I got, let's see here.
Let's do it twice. Give me the number you get using 6 zeros, and then give me the number you get using 7 zeros. And they better be the same number, or you've done something wrong.
Okay, so I got 38,786,000 789.75.
That's with 6 zeros?
Yeah. Alright, 7 zeros now.
You need it to 4 decimal places. Ah, and your calculator's not willing to give that to you, huh?
Mm-mm.
Did your calculator only go to 11 places? 11?
Well, it says as needed, so it's not necessary.
Well, it says round to 4 decimal places as needed. The thing is that I suspect there's additional numbers after the 5. It's just your calculator is cutting it off at its inability to show more than 12 digits. You know what I'm saying?
Yeah.
Now, I bet they did that intentionally. For what reason is the question. Why would they do that? Do you have Wolfram Alpha?
I would not know how to type this into Wolfram Alpha.
Okay. I've got it. Shall I give it a shot, or do you want to go on?
It's up to you if you think you could.
I don't mind trying it. Wolfram Alpha is not limited to 12 places. Question is can I type it in properly? Now the beauty of Wolfram Alpha is it'll tell us if I'm not. So let's see, I want 6 times 4.1234561 raised to the
Yeah, I got like a decimal that time, so
over 4.1234561 end parenthesis minus, whoops, let me make sure I use my minus sign, minus 6 times 4 raised to the 0.25 power. All of that divided. Okay, let me put parentheses around all of it. And divide the whole thing by 0.123456
okay, I got the same answer for 7 zeros.
Okay, let's go with it. Because I didn't get that answer. I must not have put it in there right. I'm trying to figure out why it's not right. It looks right.
Yeah, I got the same thing. 0.2048.
Okay.
So maybe
Oh,
0.204.
you didn't get that same 38 million. You got this.
Yeah.
Okay, so our answer is minus 0.2049.
I think it goes even lower. How many zeros did you do for this? 7?
6 zeros. You said you got the same answer with 7?
With 7, I got 0.20484.
Oh. Okay, then you're right. We should drop the additional digit.
Yeah.
Interesting. Interesting, because if you kept doing it until you got the same 4 digits, yeah, this is going to be the answer. All right. Minus 0.2048.
Oh my God. try 0.2049 because that's what yours rounded to, right?
Mm-hmm.
Yes.
Are you kidding me? That's not right. They are incorrect. Because if you do enough iterations, you get it down to a 0.2048. Because this digit keeps getting smaller as you, in other words, it gets to a point where it rounds down. That you ought to tell your teacher about that one.
I'll have to let him know.
Yeah. All right. Using a graphing calculator to find f prime of 3, f prime of 17, f prime for the given function when the derivative exists. Good. We can knock this out quickly because it's such an easy function to apply the power rule on. So tell me what the f prime of x is.
F prime of x would be negative 4x plus 13.
Now what's f prime of 3?
Negative 12 plus 13, which is 1.
And what is f prime of 17? That's negative 68 plus 13, negative 55. Negative 55, right?
Yep.
And minus 5. Squares to 25, so we have minus 50 minus 65. I get minus 105, 115. In other words, when I plug in minus 5 squared, that becomes 25 times minus 2 is minus 50. And then when I plug in minus 5 over here, I get a minus 65. So minus 50 minus 65 is minus 115.
Why are you squaring it, though?
Ah, thank you. Thank you for being on your toes.
It's 23.
Okay. Thank you. Just positive 23?
I believe so, because negative 2 times negative 5 is 10 plus 13, 23.
Okay. I was a...
Guess not.
What do we got? We got minus 4x minus 4 times minus 5 is positive 20 plus 13 is
33.
Okay. 30 is the last one? Looks like we got green check marks on everything else.
It goes further. I think there's like one more.
Oh, okay. 30 is the next one to do.
Yeah. 2 more after that, actually.
Okay. When they say find the rate of change relative to price, they're saying find d prime of p. So what is that?
So it would be negative 10 minus 7.
Negative 10p
P, yeah.
minus 7. Negative 10p minus 7? Is that? When the price is $9, demand is decreasing at a rate of what? for each increase in price of $9. Oh, man. When the price is... Yeah, I'm quite sure that that's got to be right. Minus 90 minus 7 is minus 97. When the price is $9,
would it be D at negative 97?
Oh, I see. For each price increase of 1. I didn't realize this was a multiple choice. I thought it was an A, B, C, D problem. I thought we had to answer each of these. I get it. I get it now. All right. So, yeah, we don't want that because it's not 97 for each price increase of $9. It's 97 for each price increase of $1.
Okay, so is demand increasing or decreasing?
Well, let's see. Demand was negative.
So it's got to be D. And wouldn't it be 17? Negative 17?
Yes. Well, now hold it. B is find and interpret the rate of change of demand when the price is $9. So what that means is the rate of change is minus $97 per dollar change. I think it's minus 97.
Yeah, that's the first thought I had.
In general, the rate of change of demand is the rate of how the demand is changing per dollar of price in terms of number of items. If the number of items is positive, demand is increasing. If the number of items, to find the rate of change of demand, substitute the price into the expression for the rate of change, which we did. We got minus 97 for each increase in price of 1. This is not that hard. It's just been a while since I've looked at this. So first of all, is demand increasing or decreasing? Demand's going to increase when you lower the price, and it's going to decrease when you increase the price. That's just basic economics, and it's also the case here. As the price goes up, D of P goes down. So it's decreasing at a rate of minus 97 items for each increase in the price of $1.
You don't think it would just be 97, would it? Because it's decreasing already.
Maybe. Well, although I don't know. Should we try it?
Yeah, why
not? God. All right. I know it.
Yeah, I'm a good guesser, I guess.
Yes. So, go on to 31 or the next one?
Yeah, the next one. I don't know. I guessed on a few of these.
Oh, you got all of them right except 31.
There we go.
This is 31, right?
Yeah.
Okay. The population of a certain bird in an area at the time t was closely approximated by the graph below. Estimate the derivative at each of the marked points on the graph. Remember, derivative is slope of the tangent line. So what is the slope of the tangent line at point A?
I don't know.
Rise over run.
I can't read the numbers.
Okay, let's see. We're going to go from 500 to 1,000 is the rise as we go from 0 to 50. So we go 500 to 1,000, so that's a change of 500. And the bottom we're going from 0, not to 50. Estimate the derivative. Okay. Oh no, the slope of one of these is 50. So the slope should be 10. In other words, the slope of one of these grids is 50. And I was figuring out the slope from this point to this point, reading it off the graph. So I'm going from 500 to 1,000. The slope of this line is 500 to 1,000 over 0 to 50. So it's got to be a slope of 10. Okay, let's use more than just one point on the grid. Let me go from here to up here. All right. So I'll go, the change in y goes from 500 to 3,500. So that's 3,000 divided by the change in x, 250. Wow, it is different. It's 12. You saw what I was doing there?
Yeah, you're just going from
Just finding the slope. Just finding the slope of this steep blue line. Just by taking points that are on the grid right there.
Okay.
Okay. Interpret the derivative.
I think it's C, right?
The population has increased by the derivative number of birds.
Actually, no, it would be D. That makes a lot more sense.
Population has a rate increase of the derivative number of birds per unit of time. Yeah.
Because it's increasing, and that's the only one that has a rate of time in it.
The derivative of the function at point B is approximately what?
Would that be 150?
Well, we got to do the same process. We got to take the change in y over the change in x. And this is not as easy to read because there's nowhere on this point. Yeah, right there it goes through a corner.
If you hit the magnifying glass at the top right corner, it makes it big.
Okay, good. So what's the slope of this line? God, are they going to make us estimate it? Wow, they are. It looks like about 800 to this point here, which looks to be about 2,700. So we have a change of 800 to 2,700. That's 1,900 divided by what? 300?
6.3 continuing.
How approximately are they going to let us do this?
Do 6.33 and see what it is.
Whoops. We try 6. I think 6. In other words, if anything, that could be 1,800 over 300. I bet you 6 is right. I bet you 6 is right, and it is.
There you go.
Interpret the derivative. Let's see. The last time the population had a rate increase of the derivative number of birds per unit of time, this has got to be the same thing, doesn't it? Nothing's changed. It's still a rate increase.
Yeah, so it'd be C.
Yeah. Are we done, or we got more?
The last question is the one with the graph that we couldn't figure out, but it's 8:30.
Well, let's just take a quick look at that and see. 22?
Yep.
Let's see if they were asking something different than what it looked like. Find the average annual rate of change for the first half of the century. Notice that this is not the first half of the century, but could they possibly mean... No, the graph doesn't begin at 2000, so you have to start here.
So it'd be 45 years they want you to do then?
It would be what? No, it's 50.
Years.
No, it's 50 years between 1905 and 1955, and the only values they've really given us are 1955 and 1905.
Did we try, because remember the other ones, even though it was a negative number, we put in a positive. Did we do that for this?
Yeah, I tried the positive number. What was it? It was 791 divided by 50. 791 divided by 50, 15.82 precisely. Immigrants per year. If you multiply 15.82 times 50 years, you're going to get a drop of 791.
Did we try making that negative too?
Well, let me use my different negative sign. Negative 15.82. I don't know how that can't be right.
Are you serious? It's 15.820. That's what they wanted?
No, I forgot. I didn't see this in thousands.
Oh. That's easy to fix. We just do...
Multiply it by... Right, it's 15. In other words, they multiplied this by 1,000. It's minus 15,820 immigrants per year. Find the average annual rate of change in immigration for the second half of the century. Okay, well, we should be able to get this correct. What's the difference between 1109 and 216?
804.
That doesn't sound right. Use a calculator?
893.
And what's 893 divided by 50?
17.86. So 17,860.
And it's a plus.
Yep.
Because it's growing. Find the average annual rate of change for the entire century. Looks like 102 divided by 100. So it's 1.02, but now I'm going to make it 1020, right? Plus 1020. Hallelujah. Is that it?
It says 4 more parts.
Oh, there's 4 more parts? Complete part
Yeah,
A through E. Oh, so I have to hit continue.
Yeah.
Okay. Average your answers to part A and B and compare the results with part C. Choose the correct answer below. The value in part C, they're not equal.
So the average parts of A and B is greater.
Well, now hold on a second. The average would be the sum of these two divided by 2. It is the same. Average your answers to A and B means we have to add this number to this number and divide by 2. And we get 1,020. So the two values are equal. Continue. Will the answer above be always true for any 2 consecutive time periods, not necessarily of equal length?
I'd say no. This stuff could happen, right?
If one of these periods was 30 years and the other was 60 years, you're right. We cannot just average them if there's different lengths. The average annual rate of change for the entire century continues. Predict the number of immigrants in 2009. Okay, we have an average annual of 1,020 in 2005, so 4 years. In other words, they're saying
80.
Yeah. Well, it's 4,080 plus this number.
Oh, plus 17,860. $21,940.
Isn't it? That's how many immigrants are going to be added over the next 4 years, but we're adding it to 11,090,000. So the number of immigrants we're going to have is going to be 11,13,080. Agreed?
Yep.
Oops. Don't use commas?
No, you don't need to.
One more continue? I don't think so, right? Oh, yeah, there is. Compare your answer to the actual number. Choose the correct answer below. That's a weird question. The actual answer is greater than our answer just by comparing the first 3 digits.
Oh, yeah.
Is that it?
Yep, that'll do it.
Okay.
So another hour and a half would put us at, what was the first hour and a half? 42.
The first hour and a half was 48, so another 48 puts it at 96.
Okay.
Okay?
And that will be to you Saturday afternoon, because that's when my paycheck will go through to my account.
That's fine.
All right. Thank you again so much.
Okay, Sean. Good luck.
All right. And just a reminder, next week, no need for tutoring, so I'm on vacation.
Yeah, I made that note last time, yeah. Okay, let's see, I need to log out of this too, don't I? I don't see a...
Save for me.
Hit save, okay. Ooh, that logged me out right there. Can you still hear me?
Yep.
Oh, and I have to sign out?
Yeah, that's fine.
All right. Sounds good. I will talk to you in a couple weeks, Sean.
All right. Thank you. Have a good one.
You're welcome. Bye-bye.